Okay, so on the bench today we have a Wells Gardner K7000 that is blowing fuses. So this will be another one in the blowing fuses series. I have not looked at it at all. All I did was take it out of the box, unwrap it, and set it right here on the bench. I do notice though that it's been capped. It has a new flyback and everything, but I don't know the situation on the bottom side of the board, if it's been reflowed or reworked or what kind of damage we have or anything like that. But it is complete. Remote board. I don't see any broken or damaged pots. It's missing the plastic holder. We do have what looks like it's burned. Well, I think I already know what's wrong with this, or what caused it. We have a big burn mark here, and the trace is burned off. And this is for our vertical position. I need to get a microscope. But yeah, the trace is completely burned here. It's gone. From right here to right here, it's nothing. It's missing. You can see that what's left of it here. Oh, it's just flaking off. Well, that's why inspection is key. Inspection is key. So we'll have to fix that. Anything else we see here? That doesn't look good, but we'll hit that. Wow, okay, so that's problem number one. Neck board, oh geez. Lots of neck board. Oh, well, man, this is not going well so far. Look at this. Wobble, wobble. Oh, that one's a bit wobbly, but look at this. Wobble, wobble. Well, that trace is broken, and I don't think that trace is broken. I think that one's actually intact, but that one is, yep, there you go. I may have just finally broken it, quite honestly, because now when I try and wobble it, it pushes through. So it was only barely hanging on, so I'll have to fix that. Look at this. I mean, if it's functional, hey, that's fine. But yeah, that's pretty bad too. So a lot of neck board butchery. So not doing too well so far. The main chassis here, we're missing the screw for the heatsink for the HOT. A lot of bent components. I like to go through and straighten all these out like a precaution. And that one's kind of smashed over, but there's no leads touching. I hope this doesn't turn out to be a head scratcher. I hate that. Okay, that seems okay. R104 is slightly bent over. R105. Oh, well, this thermistor. Look at that. Another one flopping in the breeze. Oh, come on. Slowly but surely. There we go. Oh yeah, look at that. Oh, again, inspection is key. I could have just gone to the normal components and did my testing, but you got to inspect first, because so far we've found issues with the neck board, issues with the remote board, issues with the main board here. So 3 for 3, I guess. So I'll have to fix that as well. Any of these issues could cause our problem. This would actually just be you're missing, with this out of circuit, you're probably missing a color, and it goes to this transistor, which I think is red, so it probably was missing red. Lots of components laying flat when they shouldn't be. This should be up and around there. Well, let me I gotta make an adjustment here to the camera. Let's go right there with it. Okay. This R96 here is not original. This has been replaced at some point. This R96, this big wire wound resistor, that's it's supposed to look like this one, but it's someone's put a much bigger one in there than what's supposed to be in there. I mean, it probably is okay, but it's going to induce heat onto this film capacitor and C38 and R89. We don't want that, but we'll test and see what it reads. If I have one that's correct, I'll replace it. But okay, let's start by getting a screw in here. So this stays intact. All right. Okay, well, time to test and see what we can figure out as to why the fuse is blowing. It's not going to be a neck board issue. I think what happened is this touched something it shouldn't have and burned it up, and we may have vertical collapse, because if this was ran with the vertical position pot being out of circuit, I think the vertical size is more crucial, but with vertical position being out of circuit by having this burned up trace, I don't know what kind of damage that would have caused. I need to get, before these wires break off, I need to get a zip tie on here. Okay, now our stress is on here and not on the wires. Okay, time to turn this over and see what lies beneath. We got to fix this. But none of the issues really with this would cause a fuse to blow. It may have been, but I don't think so. Let's take a look. R96 we need to replace, but okay, here we go. Oh well, it's been reworked. Not sure what's going on here. This is obviously a no connection. This here is missing all the solder. That's a no connection, but R96, I'm sorry, R89. R89 here has been reworked to this connection here to here. That's R89. No, I'm sorry, that's R96. This is R96. I'm sorry, these two connections here are 96. That big wire wound resistor in there I was talking about. R89 are these two pads here. Doesn't look like there's anything of note there. This has all been redone, so that's good. R101, that's one side of R101. Here's the other. That's been reworked. That's good. We got a jumper going on here, which is fine. This is a no connection, so that's not going to cause anything. Yeah, I mean, overall not bad. Overall not bad at all, really. Quite honestly, it's none of the flux. When the flyback was changed, the flux wasn't removed from the flyback, so we'll have to clean that up. We'll do some cleaning, but that's not our priority right now. Right now our priority is to figure out why it's blowing the fuse. So we'll test our HOT, all of our power resistors, our rectifier diodes, our voltage regulator. Yeah, and we'll check all the basic, we'll check C38, C36, all the normal stuff. We'll run through everything I run through on all these chassis that are blowing fuses. And we'll see if we can find a smoking gun. Yeah, I guess we'll start with the horizontal output transistor. Let's make sure that it's not shorted. I don't see anything obvious. I don't see any broken or blackened areas or broken traces or anything that leaps out. I don't see anything right off the bat that would explain it. So we'll go right into testing components. So, all right, HOT. We should get a 0.45 voltage drop or so, or close to 0.5, but usually around 0.46 voltage drop. 0.48, that's close enough. And the other leg. Okay, HOT is good. Critical safety cap. These are both on the same trace here, so we put negative on here and we go caddy corner to each one of these two legs. It should be the same reading off the HOT point, 0.48. Yep, 0.48 and 0.467. Close enough. It's not shorted. C38 is the horizontal width cap, and that is this guy right here, the blue cap, and that's these two pads here. We're just checking to make sure it's not shorted, and it is not shorted. We're checking to make sure that it doesn't beep. So C38 is not shorted. Voltage regulator, for this type of regulator, it's pins 3 and 4. The two wires, the red and the blue that come off the B plus resistor, go to pins 3 and 4 on the vertical one, and then the horizontal one, they go to pins 1 and 4. But the easiest way to test this is to simply go to ohms and test our B plus resistor. It should be 180 ohms, as you can see, 180. If it reads 0.0, then our voltage regulator is shorted. If it reads 180, voltage regulator should be okay. And we get 180, 182. So voltage regulator is okay, critical safety cap's okay, C38's okay, HOT's okay. Let's test R103. If that's open, that can cause fuse to blow. So we'll simply touch the two pads here. Should be 3 ohms, about 2.7 usually. 2.8, okay, that's good. Let's test our rectifier diodes, make sure those aren't shorted. That's D19 through D23, so if we hit D19, D19 is good, D20, D21, D22, D23, and D24. 0.555, that's an odd reading. See, that's 0.487, 0.465, 0.528, but 0.555 is kind of high, but not really going to worry too much about it, I guess. So rectifier diodes, okay, R104 should be 15 ohms. And it is. By the way, if you ever check R104 and it reads 0.0, you've got a shorted rectifier diode. But that one's okay. R101 should be about 4.5 or so. It's 6K ohm, but it should be around 4.5 in circuit, if I recall, close to 5. Yeah, 5K, so that's fine. Okay. R88 should be 1.8K, 1.7. R97 should be 270, and we got 273. R96 should be 1.8 as well, and 1.8, perfect. R89 should be 3.9K. Almost forgot that one. We got 3.8, so close enough. Well, your guess is as good as mine. Why is the fuse blowing? HOT, voltage regulator, C38, C36. Oh, this has the dual C36. Interesting. See how there's 2 of them in here instead of 1. But that's fine. C36, HOT, voltage regulator, C38, R96, R88, R101, R97, R89, R104, rectifier diodes, R103. None of it's bad. So why is it blowing the fuse? I'm going to assume that there's no evidence of flyback arcing over here to the frame. I'm going to assume it could be this thermistor, R105, not being in circuit. So everything tests okay, so let's solder in this thermistor. That's good. Let's add some, even though it's a no connection, let's go ahead and put some solder on that pad. The voltage regulator wasn't reflowed, so let's hit that. Make sure we don't bridge anything. Okay. Header pins for the yoke seem good. Let's hit this R89 pad there. That's a good connection there. Let's hit. None of this stuff that I'm reflowing looks bad, so I don't think any of this is the problem. But I just want to hit a couple of these points here before we test it. So if it does work, I don't think it's anything that I'm reflowing. I'm just hitting some stuff that I think should be hit here real quick. None of it looks bad. Wait a minute, what's this? What is this? Ah, our yellow wire, or brown wire here, our brown wire here from our yoke connections has a cracked joint. That could be the problem. Look at that, right there. That would definitely cause a fuse to pop if the yoke was not plugged in and ran, if this was ran for any length of period of time with no yoke connected, or at least one wire being out of circuit, that could very well do it. So look at that. Welcome to Detroit, Cracked City. I missed that. I did a very general look over and I missed that the first time, but there you go. So that's fixed now. Maybe that was our problem. That combined with the thermistor being out of circuit, that could have done something. But let's not keep or let's not go over anything by accident, or overlook something by accident, so I should say. Let's keep looking and make sure we don't overlook anything. How about that? Is that better? Is that a better way to say that? I think so. This joint here is looking kind of haggard. Let's hit that. Okay, well I think that's enough to test. Alright, so I think we may have found the problem, a very unorthodox problem. I don't think I ever seen... See these wires here, this green, it should be yellow. It says GRN and YEL, but they put a brown one in there. So those wires run over here to right off of the vertical winding of the yoke. So when you plug your yoke connector in, these two shorter pins are the vertical and the two wider pins are horizontal, and you can see that brown wire runs right to it. So if that was out of circuit at the other end here, you most likely would have collapse. However, if it'd be like having the vertical winding of the yoke not even plugged in, and that could very well blow the fuse out. I've seen it before. So yeah, this could come down to simply just bad solder joints on thermistor and the brown wire and various other pads, and we got a resistor we need to fix for the red, and we have to fix this. Let's just go ahead and take that off. Let's fix this first, then we'll go over the neck board, and then we'll power it on, see what happens. I have my circuit breaker. I did have my circuit breaker. What did I do with said circuit breaker? I had it, oh, it's out in the garage. I picked up an all points bulletin machine and I was out there troubleshooting something on that, but let's reflow this here. I really should get a microscope. It would make things much easier. Okay, we got that. Now, just to verify that that trace is actually open, let's meter on continuity mode. And let's go, as we can see, it goes to this point here. It runs this way and goes to here. So if we were to touch here and go to here, so there's the trace. If we go through across this way to the pin, nothing. We got it right there, but not right there. So let's grab some magnet wire and let's fix it. Okay, we will run this accordingly. Oh, come on. I got too much. Let's get rid of a little of that. Okay, now we can break that off, and there we go. So now we should have continuity, hopefully, from here to here. Bada bing. Alright, so let's clean this up a bit. Okay. And let's check it one more time. Got it. Do a quick visual inspection. Okay. Rest of the solder on all these look okay. We reflowed all those. We didn't create any bridges. That all looks pretty good. So, that being said, we're going to put some mask on there, but I think in hindsight I should fix this first so we can do all of it at once. We need to fix, for this we can just do a big solder bridge. Just the quickest and easiest way to do that. There we go. So that fixes that one. And this one, though, we're going to have to probably run a jumper. Now we're going to have to do probably a couple of component legs because of the amperage draw on the resistor. Or we could simply just scrape away the trace, which would probably be the easiest thing to do. There we are. Let's do it that way. There we go. All right. Bada bing, bada boom. There we go. The rest of this, I mean, seems okay. This one's lifted too, right here. Pretty bad. Okay, got that one. Well, I think that might be about all we need to do here. So let's clean it up. Okay, and I think it's time for some mask here. Let me shake this up a bit. There we go. Okay, we'll start with this, and let's yeah, call that okay. Alright, that should keep that in place and be good. Now let's take care of this here. I think that'll be okay. Wait a minute. Wait just 1 minute here. He says, as he discovers yet something else. Is that even connected? Barely. But can't tell about the other side. Yikes! Crazy. but that should work. I think that should be okay. All right, let's get back to what we were doing here now again. All right, so not pretty, but better than it was. We got our neck board issues resolved, it looks like, hopefully. Okay, that all looks all right. Let's bend these out so they don't induce heat on each other. And I guess we'll put all our pots to the center like we normally do. Wipe them back and forth. Set them to the center for a nice nominal position. All right. Now let's hook our remote board back up, and we'll set our brightness and contrast all the way down, and then we'll turn our flyback all the way down. Okay, and turn it up very slightly, and that'll be our starting point, assuming this works. That'll be our starting point. Clean off my little brush here so we can use it again. Alright, so I think I need to grab my circuit breaker and the test tube. And put all my tools away here. Okay, let's grab the tube, come back, get it hooked up, see where we're at. Alright, ready for testing. We have anode, neck, yoke, ground, power, video, and remote all hooked up. Of course, I don't have this sitting on the metal bench, it's hanging down from the side. And I do have the circuit breaker connected. Let's go around this side here. It is connected there to the posts, and it's sitting right there. So we'll power it up and monitor that, make sure it doesn't pop. I mean, you'll hear it if it does. But yeah, we are ready to go. So let's turn on our test pattern generator in hopes that it does work. And let's find out. Here we go. Sorry, I gotta unplug this here. No reason to run the board. Okay, here we go. 1, 2, 3. Well, what do you know? And I don't think we're going to get an image because I got everything turned down. Oh, we do. How about that? Let's turn our flyback down until we lose our raster lines, which will be right there. Now we can supplement with the brightness and contrast. Okay, it's called black level on these, I keep forgetting, but hey, we got blue, so we want to turn our brightness down until we lose the background. Right there, contrast. Uh-oh. No contrast control. No contrast control. Turning it up and down. That's all the way down. That's all the way up. And we have no no contrast control. Well, okay. Well, good news is it's working. We fixed the issue of blowing fuses. I think it might have been the thermistor not being in circuit, coupled with that bad solder joint on the wire coming off the yoke connection for the vertical winding. And I think those two issues might have been the issue with the blowing fuse. I'm assuming that it was. do we have all of our colors? We are missing blue. That is odd, being that we have blue on this screen. You can clearly see it, but we're missing blue on here. So we're missing blue and we have no contrast control. Each position, yeah, there we go. No blue. We did fix our vertical position problem. Well, let me make sure. Yep, that's down. That's up. So our jumper wire was successfully installed, but now we have no contrast. I need to wring those wires out, or those traces, make sure they're good. They run over to here. We need to make sure the wires aren't broken on the connections on the chassis. But okay, making progress. No longer blowing fuses. So I'm going to remove the circuit breaker, pop a fuse in, and then we'll take this back off the tube and troubleshoot the contrast problem. So here we go. Okay, so here we are back on the bench. And let's grab the multimeter here. And let's wring out our wires directly from the contrast pot to the board. And that'll take care of these connections and the wires to the board. So our connection for contrast is normally right here, CONT. So if we go from this one here, it's easier said than done. I'm trying to do this with one hand. If we go from here to the center on the chassis to here, oh, that's good. From the outside leg here to there, that's good. And from this outside leg to here. Alright, so it's not a solder joint problem here, or the wiring. Let's examine these. And yeah, those all look okay. And we can verify that by going here to here. That's good. Here to here, here to here. Alright, well, let's see what the circuit entails. So this runs over to here, which is a resistor. There's 3 resistors here. I don't think that's the issue. So if we follow this one, this runs to the other side of the resistor across here. So it's putting a resistor across the pot. Then we have this leg that runs up to here across another resistor, this way to here. This is a jumper. These 2 spots here where the trace ends, this is a jumper right here. If we follow this, we can follow it on top of the board. Yeah, so this leg of the contrast runs around here to this resistor. No, I'm sorry. It's this one. It's this leg. This one here, the blue wire. The blue wire runs this way, up along here, to here, over, and then runs underneath IC1. So if we flip this back around and follow it, it goes this way around here to this jumper, and then up here under IC1 right to this leg of IC1. Then it runs up here across this capacitor. That's a capacitor right here, this guy. So that actually ties right into IC1. Boom, right there on that leg of IC1. Now what makes me suspect IC1 is the fact that this shorted out. This vertical position shorted out and fried it. And let's see if that vertical position runs to IC1 as well. Vertical position are these 2 here. And let me zoom out so we can get all this in frame here. So vertical position is this one here, which runs across this resistor. The other leg is here, and that runs up no, that runs to this transistor. So it's possible that even though, if this definitely touched metal, it's possible that not only did it burn up this trace, but it's possible that it could have shorted this out and gone right to IC1. So I think I'm going to replace IC1 with I have a brand new one. I'm going to probably replace IC1 with a brand new IC1 and see what happens. So let's turn on the desoldering station. I mean, it's never... Oh, this screw fell out. Obviously that's not going to work. I'll have to come up with something else to fit in there. I think IC1 is our culprit, because it's not going to be these resistors. They don't go bad. And because we have a non-functioning contrast system, and we're also missing blue, not only are we missing blue, but we have no functional contrast. And I'm fairly certain that IC1 is our culprit. We can test... I don't think it's a transistor problem, because we had shades of blue on the front, on the very first screen of the test pattern generator. So I don't, if we had a bad transistor, if we had a shorted transistor, we would have all blue, and we don't. If we had an open transistor, we would have no blue, and we have some blue on the main screen of the test pattern generator. So I don't think that we have a next board problem. I think the no blue issue, or the weak blue coupled with no contrast, is IC1. So let's get that sucker out of there. While we're waiting for the desoldering station to heat up, let's grab my bag of parts here for the 7000. And this is IC2. I got two brand new IC1s right there. Oh, and while we're here, let's grab a fuse. I only got one left. Pop the fuse in. Since we know we're no longer blowing fuses, so that's good. IC2, kick back in there. And IC1 never even opened. Let's grab one of these out of here. There we go. Okay, brand new IC1. And we'll wrap that tape right around there. And we'll leave this out in case IC1 doesn't fix it. We'll leave the brand new one in and put the original one back in here, since it's not the problem. So and a big cluster of stuff here. There we go. Okay. Alright, so let's utilize our desoldering station here and get this puppy out. May need to get the soldering iron out for this one, but nope, that's good. I see a lot of people using these things incorrectly. You gotta put there's a very small surface area on the tip of this. So you have to put it on here and give it a few seconds for it to start flowing. Once you see the tip fall down and the solder start flowing, then move it around to cycle the molten solder around and then hit it. And it just opens it up nice and easy. And like I say, there's not much surface area here, so sometimes you'll have to get the iron out. Get your iron out and heat the pad up with the iron, and then suck this out with it while it's molten from the iron. And that works a lot. Well, it works better in some situations than just trying to use the surface area of this thing. And once we're done here, this should come right out. Yeah, that one's not cooperating too well. There we go. Case in point. Soldering iron helps immensely when you're trying to do this stuff. So I'm going to clean this out here real quick before I put it back on the holder. Okay. And we'll set that aside, and this should come right out. Ladies and gentlemen, it's just that easy. So we'll put that aside just in case this isn't the problem. Now I suspect this as being the problem of both our issues. No blue or weak blue and the no contrast. So if this fixes one problem and not the other, we know it was at least bad, and we'll have to keep troubleshooting. But of course we want to make sure we line our notch with the correct part there. We don't want to put it in upside down, of course. And okay, let's fold this back over here and solder this in. I also see a lot of people will do this. They'll put the solder on the tip, and as soon as they see it get molten, they let go like that. I mean, that works, but I like to actually give it a few seconds to flow. You want to give it some time to flow. You don't want to just immediately remove the iron after you see it get molten. You want to give it time to flow. Because I'll see people do this number right here like this, bloop, and so you hardly put any solder on when you do that. You want to leave the iron on there for a little bit and give it time to flow where it needs to. And that's just my opinion. And there we have it. Any bridges? I don't see any, and I do say that is a damn good job, if I do say so myself. So let's grab some alcohol here. There we go. And that's how you do it. Is this the wrong? Okay, we're good. All right. Okay, well, I guess before we try again here, we can verify that our blue transistor isn't open. We got all this done properly, so that's complete. So we'll test our theory on that momentarily, but before we do, let's verify that we don't have an open blue transistor, but I don't think that we do. Alright, so let's go emitter to base. Okay, 0.607 for that one. 0.596 for that one. 1.8. 1.8. 0.6 and 1.8 and 6. So, yep, we don't have a bad transistor. I didn't think that we did. I think both of our problems are caused by IC1. So now that that's replaced, let's get it back on the tube and see if that was the cause of our problem. If not, we'll keep going. See what else we can find. Okay, here we go. Round 2. Fuse is installed. We're all hooked back up. Let's turn our test pattern generator on. And let's find out. Did IC1 fix both our issues? Let's see. Here we go. 1, 2, 3. Okay. At least it comes back on. That's good. And well, now it doesn't appear that we have any blue. Let's try our contrast pot. I think it was all the way down. Turning it up, and nothing. Wow, gosh darn it. So much for that. Well, I was confident that we had IC1 issue. Yeah, you can, that's contrast all the way down, and that's contrast all the way up. And there's no difference. So we still have no contrast control. We know it's not a wiring or connection problem. What happens if we turn up, you can barely see the blue. Like, I don't see the blue in person at all. I see no blue in person. The camera's picking it up, but in person there's nothing. So let's turn up. Maybe it's a bad pot. Maybe it's a bad drive pot. I don't think so. They all looked okay. So I'm going to adjust the drive pot. Hey, it's the drive pot. Well, but that's maxed out. I shouldn't have to do that. Okay, the cutoff pot's back to center. Drive pot's maxed out. Turn it back down. That's maxed out. Let's try and adjust our white balance just very slightly. Okay, that's better for green. I have to turn green up too. Wow. Red, right there. See, that looks pretty darn good. Look at that. Glorious. Huh, I guess it was just a... See, I shouldn't have to turn the... Just having the blue drive pot halfway, at 50%, I should have something like this at 50%. I got this at 100. I mean, that could be the tube. So, I mean, at least it has all the colors, so I'm not really going to worry too much about that. On a good, decent tube, you've got the RGB. It could be a test pattern generator problem. That's why I like to use real boards. We'll use a real board later. But now it's good. But why don't I have contrast control? Contrast all the way... Oh, I do. Oh, I have a little bit. I have a little bit. That's down. That's up. It's hard to see. Let me get to a different page here. Different screen, I should say. Let's go back to the main one. Why? I guess... Well, not much. That's all the way down. That's all the way up. You can tell a little bit. That's all the way up, down, up, down. Maybe you can't. Up, down, up, down. Up, down, up, down. There is contrast control, but like not until you hit about 90%. Like from zero on the pot all the way up to about 90%, there's nothing. And then from 90% to 100, then it does a little bit. So that shouldn't be. That should not be like that. Well, I guess back to the drawing board. I want to figure out why that is. If it's not IC1, I don't suspect IC2. I don't think IC2 has anything to do with the color. It's all IC1 deals with the color. It still could be a neckboard problem. Well, let me get the diagram out and trace through the contrast circuit and see what I can figure out, because I should have more than just a 10% control on the contrast, and I shouldn't have to have blue up that high to get blue. So yeah, because with the green pot at 50% I had green, with the red pot at 50% I had red, but with the blue pot at 50% I had nothing. And I have adjustment on the cutoff, so the cutoff pot's not broken, the drive pot's not broken, but how come blue has to be 100% to get blue? I don't think it's the tube. So I'm going to dive further into this, and I'm going to figure out, see what I can figure out, and I'll come back and we'll discuss what I found, if anything. So stand by one moment. Okay, so please excuse the crudity of this screen capture here. I'm just using my phone to capture the screen because my software died. But you can see here's the contrast circuit right here. This VR7 is the pot. And we already know it went over to IC1 because I changed IC1 out and that wasn't the problem. But if you notice here, it also has a leg that goes to ground, has a leg that goes through R25, R26, and then right to Q8. Now the brightness control also runs through Q8. So the only thing that can explain this, if IC1 does not fix the problem, we're looking at a problem with D9, or we're looking at a problem with Q8, because I can guarantee these resistors aren't bad. 25, 26, 27 to ground, 24. I can guarantee these resistors aren't bad. I'm betting it's either a problem with D9 or Q8. So let's check those components out and see what we find. Okay, so Q8 resides right here. And it appears to be intact. However, it's very tall. If you look at the rest of these, they're closer to the board. See, this one here and these three for the color RGB. They're much closer to the board, and this one is standing up tall, like someone's already replaced it. And not only that, the legs are kind of bent. See the legs on there? They're kind of cattywampus. They're, instead of being straight, they're bent backwards. So I don't know what's going on with this. I'm wondering if somebody replaced this with the wrong kind. But we're going to replace this with one from a donor board and just see what we get. But before we do that, let's just test it, because I want to see if it's giving any kind of anomalous readings here. So diode checker on the meter, and Q8 is this guy here, which corresponds to these pads here. So we'll go center with negative, and we get open to there and open to there. If we go here, we get 0.6 and I don't think that's right. It's climbing. Let's go here to here. 0.6 and 1.4. See, I don't think that's right. It should be 0.6 to each leg, I'm pretty sure. So, okay, check this out. With the negative lead over, I don't know which one's base emitter collector. I'm too lazy to look it up. So if we go to here, and we, with our negative lead, and go to the center, we get our 0.6 voltage drop. The other outer leg is 1.4. Let me grab another 7000 that I have sitting here somewhere. Where you be? How do you do? Where do you be? What do you say? Alright, so we got a donor one here. So now if we do the same thing and go outer leg to center, 0.6 and open. See how that's open? We got 0.6 and open. If we go back to this one and we do 0.6, here we got 1.4. So if we go back to the center, that leg is open, and that leg is open. On this one, center, open, open, so that's normal. This side, 0.6, 8.3, and Now I'm starting to wonder if it's bad. I don't think that's bad. What was the D9? D9 was the other component in that circuit. We gotta find D9. D9 is right here. That's this guy right there. D9, we're in diode checker. And if we check D9, 0.581, that is good. Just to make sure. Yep, so it's not D9. So if it's not D9, and it's not IC1, and it's not the pot, the only thing it could be is Q8. And I'm very suspicious of Q8, being that it's obviously been replaced and the legs are cattywampus and all that jazz. I should not have to turn the pot to 100% to get blue. So I put it back at 50. So let's replace Q8 and see what we get. And she's out. Someone's definitely replaced this in the past too. Alright, see, here's more of what I expect to see. See how close that is to the board? That's more like what I expect to see. So let's get this off of here. Alright, just that easy. And just in case it's not Q8, I'm going to leave this off to the side so we can put it back in. But here's the one that we took out, and here's the one that we're going to put in. And you can see just how different it is. So I think this has been replaced at some point. So we'll set this one up here aside, and we'll reinstall this one out of the other donor board. And because this also affects brightness, and I think I had brightness control, but I don't recall testing the brightness control, quite honestly. If this doesn't fix it, then we've got something going on with those resistors that I said never fail. Or I did not suspect them as being failed. Okay, so we have successfully installed the replacement Q8. So, actually I kind of want to lower that down a bit. There we go. Alright. Let's make sure we don't have any open traces. This should go through there. Nope, that goes right to it. Okay. This one goes through it over to here, and that one goes straight to here. Okay. Well, yeah, it's all connected. Q9 didn't look very good, but Q9 is part of the vertical hold, and we had vertical hold, so that wasn't a problem, but the solder joints didn't look very good. Alright, so let's clean that up real quick. Okay, let's get it back on the tube and see if that fixed it. Alright, all hooked back up, ready to go. We changed out Q8, and I have the blue set back to 50%, so hopefully we'll see some blue, and I'll have full range of contrast. We need to check brightness control. I don't think I did adjust the brightness, but I want to see if I have full brightness control, because that goes through Q8 as well, as we saw. So let's go ahead and turn this on. I left my test pattern generator on this whole time. That's not good. All right, let's see. 1, 2, 3. Okay, it comes right back on. Hopefully we have some blue here. Crap. We do not. If I turn up contrast all the way up, oh, let's see, there's some blue. So contrast all the way up. I turn it down and it goes away. So I have contrast control, but not the full range, because right now it's all the way off. Turning it up, turning it up, turning it up, turning it up. There we go. So it's not, I only have actual contrast control in about the last 10% of travel of the pot. Brightness control. Oh, I got full brightness control. So Q8 was not the problem. IC1 is not the problem. Why don't I have... I mean, it works, but I only have... It only works in the last 10% of the travel. If I... Let's go back to RGB. Okay. So that's red at 50%, green at 50%, blue at 50%. I have to turn the blue up to 100%. Right there's 100% of the drive. I should not have to do that. It should be able to accomplish this amount of intensity at 50%. So I am half tempted to swap out the neck board from off a different 7000. I am half tempted to try that, because I can almost guarantee that those resistors in the circuit are not bad for the contrast. I'm wondering if there's something going on with this neck board, one of these resistors at a tolerance. Let me do that. I am going to swap out that neck board and put all the pots at 50% on the replacement neck board, plug it all in, and see if we have our working blue at 50% and our working contrast full range. Because at this point I'm suspectful of something on the neck board. So let me try. I'm going to steal a neck board from a working chassis, throw it on there, and see if that makes any difference. So hang on one second. Well, swapped the neck boards. It made no difference. So I put the original neck board back on and kept going. I thought, well, you know, maybe it's a picture tube problem, because I could not find, you saw everything I did, including swapping the neck board. I didn't show that, but it didn't work. So I did everything imaginable and I couldn't find the issue. So I thought, well, maybe let's try a different tube. So I went and got a different tube that's compatible with the 7000. And as we can see here, I have the blue, that's all the way off, that is 50%, that's 100%, and as we saw before, we had to have the blue at all the way to 100% in order to get any kind of blue, and we had almost no contrast control. So now I've got, where are you out of focus? So now I've got the blue set to 50%, along with every other pot. They're all, as you can see, 50%. Oh, no, they're not. Sorry about that. There we go. Okay, 50, 50, 50, 50, 50, 50. Okay, so now we should have equal red, green, blue with all these at 50%, and we should have good contrast control. So let me turn our test pattern generator on. Let's turn this rig on, and let's see. There you go. Let's go to our color bars. There you go, RGB. All the pots set to center. Good blue. Let's adjust our contrast right here. Let's turn it up. Hold on. There you go. Wow. Okay. Down. Up. Let's go to a different screen here. Let's turn it off and back on. There we go. Okay, down, up, wow, okay. Full contrast control now. Brightness, let's adjust our brightness to right there. Contrast, yep. So all of our problem, the whole time I was troubleshooting this, it turned out that my tube that I was using for testing had a weak, well, it didn't have a weak, but it was weaker. The blue gun on my tube was weaker than the red and the green. And that's all it was. So all that time, all that headache, all that trouble turned out to just be a bad tube. So, well, not bad, I'm sorry, I keep saying that. It's not, the tube was fine, just the blue gun was slightly weaker than the red and the green. That's why I had to max out the pot. But as you can see with this one, with all of them set to the middle, 50%, this one's beautiful. So that's all it was. Nothing was actually wrong. All that time and effort was just issue with the tube. Got a different tube and we're good to go. So that being said, let's go ahead and turn off this. And as you can see, this is meant for a U5000, so I have to put this on here to keep that from shorting out. But let's plug in the video signal from Mortal Kombat here. Let's see how that looks. Alright, we're going to have to do some more adjusting here. That's good already. Black level roughly there. And contrast. And now we need to adjust our colors here. Not that it matters because it's not staying on this tube, but I still want to make it sure it gets at least a decent image here. Let's do blue a little bit. And oh, just blue a little bit. That looks pretty good. Just turning the blue up a bit. Look at that. Yeah, nice. Let's turn the contrast back down just a little bit. There we go. Brightness. Awesome. Each position roughly there. Width's a bit too big. Let's make sure we can adjust our width. Let's grab our tool here and put that in there. Oh, this is all chewed up. It works okay. And yes, awesome. Look at that. Beautiful. Yep, so all that time it was just a weak blue gun on the tube that I was testing with. So I'll have to make note of that and see if I can zap that blue gun a bit higher, get some more life into it so I don't run into this problem in the future. But that's it. So we are repaired, we are fixed. So the only real issue we had was bad solder joints on the thermistor, R10, what was it, R104? I think it was? R105. That R105 thermistor had was basically out of circuit. We had bad solder joint on our brown wire for our vertical deflection. And we had a bunch of bad solder work on the neck board that needed fixed. I'm sure there's a couple other things I'm forgetting. It's been a number of hours. So anyway, yep, it's all good to go now. So I was thinking about editing out all the contrast problems, but in full disclosure, I don't like to leave stuff out. So we all learn better that way. So at least we know now if we have no contrast, if you have a K7000 with no contrast control, at least now you know how to troubleshoot the circuit and what to look for. So thanks for watching. Hopefully you learned something. Like, share, and subscribe. I appreciate it. And another one chalked up to a nice repair. So I have a bunch more stuff on the way. Like always, there's never any end to the content in sight. So stay tuned for the next video, and we'll see you then.